Mathieu. Thank you so much for joining us. Friends, Mathieu is an electronic engineer, and he'll be presenting. I like the way he's titled the name, Multipass Open Source Hardware Authentication Framework, providing it's completely open source. And Mathieu, I wouldn't want to delay your time, so you could start your presentation.
Okay, thank you for the introduction.
It was a very short introduction, but I didn't want to delay the time. Yeah.
It's fine. Don't worry. I'll make an introduction as well. So I'm going to interrupt your screen sharing so I can share mine.
Yes, go ahead.
There you go. So this, you should be able to see my screen now.
Absolutely.
Great. Thanks everyone for joining. So this talk is going to be about the Multipass. So I'll actually have a slide where I present myself. So I'm a embedded systems engineer. Like other speakers at Hardware, I was also a writer for hackerday.com. Have some blog where you can see a few projects I do during my spare time, and I'm the Multipass project founder. So what is the Multipass ecosystem? The Multipass ecosystem is a complete ecosystem based around some hardware devices. And this ecosystem aims at allowing you to store credentials, small nodes, files. It also allows you to authenticate on SSH servers. Also allows you to authenticate using WebAuthn. So the different points I'm actually presenting here, I will refer to them a bit later during the presentation. So WebAuthn, in short, it's a passwordless authentication technique. We also support time-based one-time passwords. The devices allow multiple users. Multiple users can use the devices that we offer. The devices can be used on multiple platforms, may they be Linux, computers, macOS, Windows, smartphones, iOS, Android. We also provide some extensions to allow native credentials recall in your favorite websites. And the complete ecosystem is actually open source, open source software and open source hardware. So all the design files for the hardware devices, for the extensions, for the software, everything is online. I'll give the link at the end of the presentation. So as I was saying, the complete system is open source. We have contributors from all over the globe. So this is a quick world map of the interesting locations of our contributors. So going back to the Multipass ecosystem. So as I was saying before, the Multipass ecosystem is based around devices. So on the bottom, I'm not sure if you can see my pointer. I don't think so. So I will give locations. So on the bottom of this slide, you see one of our devices. This device may be connected to your computer, smartphone using USB or Bluetooth. So we present different communication channels. Some of them are HID, which is an acronym for Human Interface Device. That means that when you connect your device to your computer, it doesn't require any driver. It doesn't require any special permissions. I know, for example, that some companies actually have some very strong restrictions about the kind of hardware you can connect to their computers. So this is basically recognized as a keyboard. So we have different communication channels that basically facilitates the way for you to authenticate onto websites. So using login passwords, we provide some tools to actually log into SSH servers using SSH agents. As I was previously referring to, we have passwordless WebAuthn support, which is basically a public-private key authentication system. I will refer to it later. And we have a few software frameworks that if you don't want to, if you want to actually script the way you interact with the device, this would be a good starting point. So going from nice icons into actually words. So these are the different elements that we provide, may they be software or hardware. So I will start discussing about the hardware side of things. So the Multipass hardware devices. So the Multipass project actually has been going on for the last 7-8 years, something like that. It originally started as hackaday.com sponsored community project. So there was a call for contributors, and seems the idea of offline password-based password keeper was quite interesting to some people, and from there it spawned into a lot more, as you will be able to see later. So from 7 years ago, we actually created 3 different devices. So you can see the evolution from a big one, which was a bit more aimed at desktops, into something that is a bit more portable, especially one that provides Bluetooth, which is completely standalone. You don't need the device to be connected to your computer to, for example, display logins and passwords. So the complete security model of the Multipass devices is they are aimed to be tamper evident. So the devices are made in aluminum, and we design them in such a way that any attempt at getting into the insides would lead into visible marks. So here you can actually see a slide of me trying to see what kind of how resistant or how tamper evident actually our case would be. I'm going to then concentrate into talk a bit more about our latest device. So this device, so this is the Multipass Mini BLE. It is a device that we have been working on for the last 4 years, 5 years, something like that. And basically it was, given that it is a contributor-based project, we had a lot of time, if I may say so, to actually work on it and to actually develop something that we really wanted to provide to anyone while being open source. So for this device, we actually inserted 2 microcontrollers into them. So on the Multipass Mini BLE, you have one microcontroller that you can, the secure one, basically, which is only dedicated at storing, at doing all the security or the sensitive operations. It is the one who is going to decrypt your credentials, the one that is going to display information on the screen, the one that is going to display all the information. And you have a non-secure microcontroller, which is just a term to say it is the microcontroller that is going to deal with the outside world. It is the one that is going to interface with your computer using Bluetooth or USB. It is the one that is the most exposed, but it is not the one that we on which the complete security of the device relies on. Expanding a bit more onto that, so there is one microcontroller that is dedicated to the secure operation, decryption of the credentials, displaying information on the OLED display, and there is the other one that is dedicated to the outside communications. And the communications between the 2 microcontrollers is really old school. It's like a serial link with a fixed frame with just, okay, given message type, okay, please give me the credential for that particular website, one of the numerous examples. So as I was saying, the goal is that all the protocol stacks, may they be USB or Bluetooth, if I'm pretty sure that if you follow the recent news, like there is always a new bug or some interesting vulnerability that is found into the Bluetooth stacks. So here, basically, all the protocol stacks and all the complex libraries are directly offloaded into the non-secure microcontroller. So this allows us to make sure that if it is compromised, then it is not going to compromise all your credentials. It's really something that is set apart and minimizing the interactions with the most secure microcontroller. It makes things complex, but makes them interesting as well. So actually, what it actually looks like. So you have the user that wants to unlock its credential database that is going to insert its PIN onto the secure microcontroller using the scroll wheel. This PIN code, so we have a way of authenticating the smart card that we can go back to it later. So it's going to insert its PIN code into the secure microcontroller. This PIN code is going to be sent to a smart card that contains the encryption key, AES-256. This encryption key is going to be sent once the PIN is validated. This AES key is going to be sent to the secure microcontroller that can then decrypt the credentials of said user. And after using USB or Bluetooth, these auxiliary microcontroller will be able to query the secure microcontroller for the credentials. The user will be prompted for approval or be notified, depending on the user preference. Microcontrollers, so they are off the shelf. They are from Atmel, or now Microchip. They internally store the unique encryption and signing keys per device. So that means for each device, for each microcontroller, we have a unique encryption key that allows to send custom update files. So if, for example, one encryption key is compromised on one device, it doesn't compromise the rest of the park or the rest of the other devices. And the device themselves can be updated using uniquely signed firmware updates. So one may wonder actually how we actually flash these microcontrollers with the unique encryption keys. We actually do it ourselves. We designed our own custom-made programming jig. So for a few days, we actually take the microcontrollers one by one, put them on the programming slots, and we have everything programmed. Quite fun, fun days. So now I'm going to speak a bit more about the firmware features that we provide. So AES encryption. So the good saying goes that you don't roll out your own cryptographic routines. We didn't, of course. So we are using bare SSL in counter mode. We are in contact with the creator of the library, who is extremely nice, who helped us make sure that we were not making any mistakes in the implementation of the different cryptographic routines that he would provide. We made sure that the way we used NESI vector sets, that we didn't make any mistake. It's always good. Encrypted storage. So these routines are used to encrypt the different credentials you have on your device. So we have actually a dedicated flash memory that is aimed at storing the credential data. So we have two types of data. We have credentials, logins, passwords, the usual one that you use to log into your website. And we have web-audit data, which is basically like the passwordless authentication feature that actually I referred to before. And the other type of data is actually encrypted blobs. So what I mean by encrypted blobs is like small files, small nodes. So the device itself can actually store like small, for example, recovery keys of your Bitcoin wallet, or small nodes, some secrets that you want to store. We're not aiming to store gigabytes of data. We just want to store like the most critical data that you're interested in. Internally, it's a sorted linked list data structure. So actually, the small animation you're seeing on the right is actually, comes from our emulator. So you can actually test, you can actually try the complete Mooltipass ecosystem without even having a hardware device. Like we have device emulators for Linux and Windows, macOS not yet, but soon. And as I was saying before, the Mooltipass device can actually allow more than 100 users to store credentials on. Smartcards. So we basically smart card from Atmel, which is pin locked. The new device is actually, we selected the pin mapping in such a way that we can start transitioning into other forms of secure memories, because we don't want to be dependent on only one kind. So like in the future, you may expect support for more secure memories. So basically, the users enters its pin on the display, as you can see in the small animation. Then if the pin is validated, then the AES key is recovered from the smart card. Random number generator. It's always fun to try to find ways of getting random data. For this device, we found a few papers online that were using the least significant bits of accelerometer data. So the accelerometer on the device is outputting 16 bits output words. And when you're sampling, when basically you're sampling 2G, when your sampling range is 2G, you can be sure that the last 4 or 5 least significant bits are going to be pure noise. So just to make sure we are using the last two least significant bits. The quality of our randomness was extensively tested using die-harder tests, and on our device itself, we have a few routines to make sure that the data we are getting is actually random. Communication with the outside world. So the device communicates with your computer or smartphone using Bluetooth or USB. And the protocol on these links is actually HID, Human Interface Device. So when you connect the device to your computer, it's detected as an external keyboard and also presenting another proprietary, which basically means that it's random, is sending some custom data. So we have the proprietary channel for facilitating the management of the device, and like the interesting, for example, credential recall feature that I mentioned, where you go to a website and it authenticates for you. This is done through the proprietary channel. But we also have a channel that is dedicated to simulating key presses. So what I mean by simulating key presses is that the device itself can simulate key presses in order to make your computer believe that it's you typing on your keyboard, pressing A, B, C, the different keys. What is particularly interesting on this feature is that I'm pretty sure some of you may know, your keyboard actually doesn't send the character to your computer. Your keyboard is going to send the physical location of the key you're pressing, and then the translation between the physical location of this key to the character that is recognized by your computer is up to your computer. So for example, on your computer, for example, I have a French layout that is configured. Some may have Slovenian, like we have different countries. So the Multipass needs to do the translation between the character that needs to be typed and the sequence of keys that needs to be sent to the computer. So that means a lot of lookup tables between characters and key codes. So these were generated by parsing the Unicode Common Local Data repository. So there is a great website, which is cldr.org, that basically tells you, okay, if you want to type that character, this is the sequence of keys you need to mention. We'll briefly mention the interesting facts of different accents, like in French, we have a lot, A, A, like the circumflex accents, all the different key combinations that you need to handle in order to properly type Unicode, which was quite interesting to implement. But the upside of this is once you've implemented all the scripts and once you've added all the lookup tables into the device, that basically allows you to type any password on any kind of device. By the way, I'm seeing some questions in the chat. Do not hesitate to ask me. Someone asked if when it will be available to purchase. It's actually available to purchase on Tindy. Web button authentication. So the project, as I said, the project itself is open source. Like everything is online. We don't have any secrets except the encryption keys, obviously. So, for example, one of the amazing contributions that were done was a single contributor that actually, by himself, implemented passwordless authentication, so web button, which is also called FIDO2, the successor of FIDO, Universal Second Factor. Is basically an uprev of that thing. So this contributor, by himself, actually updated the firmware, added the features on the auxiliary microcontroller and the main microcontroller, and because of this, now allows us to benefit from passwordless authentication. So at the bottom of the script, at the bottom of the screen, you can basically see how that works. So basically, when you want to log into a website, like when you want to register to a website, that website is going to send you a public key. You're going to generate a private key. Then basically, it's like there's going to be an exchange of public keys, and from this, you will be able to seamlessly log into the website by just signing challenges. It's as simple as that. Support by different websites is ongoing. It takes a little time. We are in contact with major websites for different details that we are noticing. So like if you want to spread the web Authn word, it's highly welcome, because we are seeing some websites that basically only want to, that say that support Fido and Fido 2, but concretely they still want to go on Fido. So like the bottom line is that it's still work in progress, but we, at least on our side, we are good, I think. Graphics library. It was designed from the ground up. So as I said, this is our third device. We came a long way from the first one. On the third one, we wanted to do it well. We wanted the experience to be really nice. We wanted to have a nice interface. The animation you see is actually what you would see on the device, except that the screen is blue, it's not white. And on each device, more or less, there is 1,000 bitmaps. So like we support different animations, all that stuff. Like we wanted to have, we wanted a nice interface on the device. So we have run length encoding compression, so we don't use all the dedicated flash that is all the flash that is dedicated to storing bitmaps. We support multiple fonts. The fonts are pre-rendered, so I think on the device right now we have 5 different fonts, depending if you have prompts, if you have notifications, if you have, like, for example, subtitles on the screen you're seeing now. So like, just we really spent a lot of effort trying to make the user experience nice. On our first generation devices, we had like 1 or 2 fonts, one for like prompts and like one to display credentials. That was pretty much it. As I was saying, we have a dedicated data storage flash that stores lots of data. So as you saw before, we are storing bitmaps, we are storing fonts. Not only that, we also have, for example, we have an interesting problem, never mind. So we have bitmaps that are dedicated to the language that is selected by the user. So user may choose on the device itself the language that it wants its device to be. So we don't you don't need to update your device to support to be in French. Like everything can be selected on the device itself. By the way, if you want to contribute to adding more languages, highly welcome. In short, it's like we have a text file of 150 strings, more or less, that you just need to translate. So we, as I said, we implemented a read-only file system that also stores firmware updates. The complete flash is CRC checked and CBC MAC checked. I'm pretty sure a lot of you know that checking the integrity of a bundle is always challenging. Unless I'm mistaken, like one of the last hardware talks was how the Nintendo, one of the Nintendo game console was so how we could add more games by just using one of the techniques of the badly chosen CTR integrity checks. So here we are CBC marking the complete flash. Not selecting. There you go. Okay. Other noteworthy feature that are most of them are already mentioned. Not only did we want to make sure that the user experience on the device was nice, we also wanted to allow the user to select the trade-off between security and user friendliness. Like it's always we always have the same discussion. It's okay, do you want the device to be intrusive? Do you want to be prompted for every device or every operation you're going to do on the device, or do you want to let the device do what it wants to do? So like on this device, on the device itself, you can actually select the behavior of the device. You can actually select between being prompted for every single notification. You can select, okay, you can tell the device, okay, please show me your authentication hashes. Like we have a complete set of features that even the most security conscientious people can actually use the device, but also, for example, my grandmother. Something like that. So we really want to cover the complete spectrum and to allow you to select the behavior of the device itself. On the device itself, we have we have a nickel metal hydride battery, so old school batteries, but we actually have a lot more discharge charge cycles than the lithium ion counterparts. So we design our own charging algorithms, our own state of charge algorithm. So that's more or less it for the hardware device. I'm going to I still have 5 minutes left, I think. I'm going to mention the software side of things. On the software, we have a companion user interface, Multiqt, which was originally designed by one of the contributors. Then we have a few freelancers working on them on the user interface that allows you to completely customize the behavior of the device. Also allows you to browse the different credentials stored on the device. So this is, for example, me looking at the different credentials stored on the device, changing the logins, seeing when it was last accessed, last modified, specify the category of the credentials, and a whole bunch of different settings. As I was saying also, the device can store nodes, can also store small files, like many recovery keys I mentioned before. Also allows you to, so not only multiple users can actually use one device, but actually one user can use multiple devices. So that creates the challenge of synchronizing the database between different devices. So we have a few tools to actually facilitate that. You can use one device at home, one device at work. And if, for example, if you have a Dropbox or some share, you can have Multiqt monitor that file in order to make sure that your device is up to date. One quick mention I want to do is that these export files together with a smart card reader and your smart card would allow you to recover your credentials in case of if you break your device. So like I want to say there is no vendor lock-in. So once you have the Multipass, like you're not locked into the Multipass. If one day your device breaks or you're just tired of it, you can take the export backup, which is encrypted using the ACE key of your smart card, use a smart card reader to recover your ACE key and decrypt your complete database. So just like this, there is no vendor lock-in on that one. I want to make it clear. We have a few other tools. We have, as I mentioned, browser extension, Chrome, Firefox, Opera Edge, Safari, kind of. So Apple keeps changing the stance on the web extension support. It has made things quite interesting over the last few years. So in short, you have the extension installed on Chrome, Firefox. You go into a website, it will automatically log you in. You will be either notified or prompted on the device, and you will seamlessly log into the website. We also have a command line tool that is shipped by default in your Multiqt installation. Here, basically, you can see me querying the device for the test service, and directly in the command line, you can get the password stored on the device. We have an SSH agent, which is not which recovers the private keys from your device in order to authenticate you into SSH servers. But you may have seen that recently OpenSSH has started supporting FIDO2 or WebAuthn authentication. So actually, right now, if you there's a few comments, we have a few tutorials, like you can set up your server to use WebAuthn or FIDO2 hardware devices to log in. So actually recommend that, but if you have old generation servers that requires RSA keys and all that, we also have an SSH agent that allows you to log you in seamlessly. We have a Python framework. One of, well, actually I have two. First one is for the Multipass Mini first generation device that is a bit more complete than the one we have for the Mini BLE. If you want to script operations on your device, basically we provide a few files that allows you to interface with your device using Python. Here you see me querying some details about the Multipass I have. That's pretty much it on the software side of things. Contributors are highly welcome. One thing that is strongly lacking from what we have right now is better integration with smartphones. So actually, you may know that Android or iOS has some autofill services that basically whenever you want to log in on your smartphone to any service, like you may have hooks into some Android or iOS services to look for credentials. So actually, in theory, by just implementing the simple app on the smartphone and the right service on the device itself, we could have native integration with smartphones. So this is something that we really think like could help a lot of people, because right now you can the only way to interact with your smartphones is using native credential recall. So on the device, you select which credential you want to send to your smartphone. And that's pretty much it. If you want to contact us, we move from Freenode to Libera. This is my email address. At the bottom, this is actually the link to our repository. If you have any question, you're welcome. I was monitoring the chat and didn't see that many questions. If you have questions, you're welcome.
Thank you so much, Mathieu. I see that there's somebody who already posted about the product being available in July. So thank you so much for creating such a wonderful tool. Anybody has any questions on the product, the tool, or if you would like to contribute to Multipass, it would be nice.
We'll also mention that components shortage is so. The device is actually available. You can build. We actually had a few contributors building them devices themselves. We sell it, but the components shortage makes it like tough. So it's actually available on our website. It says it's available in July, but if you look on Google, you will be able to find it.
All right. Martin says you answered all his questions in the talk already. So that's good. Maybe Mathieu, I do not know if this is something that you have thought about with the team, but do you want to share about, what are the future features that would be available in the future editions?
So actually, I'm actually opening right now the issue. So we are making extensive use of the issue list on our GitHub repository. So if you go to github/multipass/MiniBLE, go to issues, we actually categorize each issue as feature requests, bugs, and stuff like that. For me, really, this would be integration with the smartphones because it would make things way easier. We have a few feature requests on additional delays. Like there is, depending on the computer setup of each person. For example, we had someone saying like we have a feature that basically you insert your card, you log in, and it will offer you to send your credentials for your computer. So like let's say that you have a Windows device logged by default, insert your card, it will prompt you to send the credentials for you. And on some interesting setups, like you need an additional delay. So there is a lot of small features that are actually really easy to get into the Multipass ecosystem that actually have a strong impact on people that are actually using the device. People that have like organization managed devices that have interesting setups that require some small fine tuning of the device itself. It's a small feature, small stuff, but actually that has a lot of impact. But okay, going back to your questions, like for me, it would be integration with better integration with smartphones. This is the one that pops up the most.
Okay, that's nice to hear. Any other questions from the audience? Okay. Are there any plans for what comes after the Mini BLE? Also, I think I remember older devices having limited space for new firmware features. How is the Mini BLE doing on space?
We're still good, 50% on the main microcontroller flash space. We had 50%. So on this one, we still have margin. Honestly, if you have a lot of time to implement, a lot of time to contribute, you could implement your Bitcoin wallet on it. But like always, it's always the time of the contributors that is precious.
Okay, I don't see any more questions, Mathieu. So yeah, Mathieu, thank you so much for sharing the tool and contributing it to the community. It's really nice. And also thank you for sharing it on hardwear.io. Friends, we will open the breakout room now to interact with Mathieu if you like to talk about his project or just something else related to the tool or his previous research. Feel free to do so. There will be a pop-up onto your screen now to join the breakout room. Thank you so much, Mathieu.